and we'll hear from them about how they their thoughts about integrating technology into to reach net zero and how they think about that for the next hour or so, looks like, and then we'll have questions at the end. It's a pretty small group, so feel free to jump in if there's specific questions you want to ask as well as we go. So with that,
Phil Williams. Really have touched a lot of different parts of the supply chain. I got started early in my career with United Technologies Carrier, so I was always been a building scientist kind of guy, big commercial buildings from hospitals to semiconductors, and really started to recognize, I guess my first opportunity to sort of see the sustainability world was when all the refrigerants that every major manufacturer had were going to be outlawed. The ones that were most efficient, were the safest, were the cheapest, most readily available, were going to be against the law. So I'm also a firm believer that sometimes fear and pain, or the fear of pain, are the biggest drivers in terms of making significant change. I think some technologies can be revolutionary. I think some can be evolutionary, and some can migration. So part of me was, when I was looking at the entrepreneurial room, I was wondering how those technologies may have uses above and beyond what they saw as their initial market segment, not to leave people without focus. I'm a mechanical engineer by background. I've been engaged, again, throughout this trade, actually stamped some drawings in my life, so I was responsible for it, worked for a great design build contractor in Southland Industries, so I was responsible for not just the equipment and the design, but the installation and functionality of it. Up until about 3 years ago, I was with Webcore Builders for about 12 years. I headed up their engineering group, I headed up their sustainability consulting, and I think probably everybody in this room is either the 1 or the 10. I don't think you're the 90. Our job is to identify the 1 and move it from 10 to 90. The ability to sort of make that transitional, whether you're a connector or a lubricator, to get things going forward. The last 3 years I switched. I've still been in the built environment. I'm with Delos. So we're all about creating healthier, higher quality places for people. Not in any way to sacrifice net zero energy or to not care about the planet, but to recognize sustainability is the planet and the people in it. Business model's pretty clear, I think. You know, we spend 90% of our time in buildings. We spend 90% of our money on our people. There's a very interesting connection that ultimately potentially has a business model that could be more impactful than the energy component, because I hate to say it, energy is 1 to 3%, people are 90%. But I would encourage anybody in this business to recognize that you need to have a dual threat. You need to be able to have energy efficiencies, and you also need to be able to create healthier environments for people, more productive environments for people, because that's what most businesses are about. And the ability to link both of those may be key to any new product that has multiple uses. So that's where I'm going to leave it at that a little bit, and I'll move it on.
Well, thank you. So I'm Kevin Powell, and it's actually a great privilege to be part of this panel. I'm going to thank Ruth for having invited me, and of course I've actually worked with all of the folks up here, and an incredible group of people. And you know, I think building on what you just said, so I guess by background I'm an architect. There's a great Yogi Berra quote that says, if you don't know where you're going, any path will get you there. I started out probably in that place. I read a couple of books when I was undergraduate at Columbia, a book by Chris Alexander, The Pattern Language, and actually a remaindered book on a table called Architecture and Energy. And I put those two books together and thought, as you say, we build buildings for people, but those buildings have an incredible impact on our resources. And back when I was going to school, it was a long time ago, but in the 70s, the idea of energy efficiency was kind of a novel idea. It was probably about as debated as climate change maybe by some today. Anyway, with that said, I've been really fortunate over the course of my career to have been able to put a lot of this in practice pretty much ever since. So for about 30 years, I've been working in this field of sustainability. When I started working in the field, if you wrote sustainability or word processor would identify it as a spelling error. It was not actually an accepted word, which is sort of hard to imagine in 95 or so. So it's been actually a great journey. I've also been very fortunate. I was able to work with David Gottfried really at the beginning of my career, and really at the beginning of his career when the U.S. Green Building Council was a half-time person. When a meeting of the big USGBC meeting was less than 50 people, where David really was concerned at that time that USGBC wouldn't take off, that the LEED standard wouldn't take off, and the reason was that he felt too much uncertainty in that real estate community, came from the real estate community, about essentially the true real world performance of technologies that could deliver on these kinds of the kind of performance that was needed to have sustainable buildings. And that really has been what I've focused my career on ever since, right? So it's been really essentially proving out next generation technologies in real world settings. And I've been doing that for the past 13 years with GSA, federal landlord, on all of the basically all the real estate that the civilian government works in. So there's about over a million people who work in that space, more than 380 million square feet of that space, largest single commercial landlord in the country. And that scale lets us really try things out. It'd be very hard if you were owning a single property to actually make the kind of investment to really see if something works. But we're able to do that. That is the program that I've been running. And we'll probably talk a lot more about how some of that works as we go forward.
Sure.
So my name's Cole Roberts. I work in the San Francisco office for a company called Arup, which I don't know how many people know. It kind of floats underneath the radar often. It's a fairly large organization, about 15,000 people around the world, and give or take 90-odd offices. So it's sizable. In our San Francisco office, we've got about 300 people, and I lead a team around energy and sustainability. And I end up doing a lot of research, a lot of work on more vanguard innovation-focused projects. A couple things that kind of bring Arup into this conversation, I think, that since this is a topic about research and innovation and scaling, is that Arup is a fairly unique organization because it's large, but it's an employee-owned structure. It's not publicly traded. We're not held by any individuals necessarily. It's all held for the employees. And all of the profits from the organization float to one ethereal place when we make some money, and that ethereal place then allows the profit to get redistributed out to the employees as profit share, and then is some money for research and innovation. So we don't generally do our research on projects, so to speak, because that's spending our clients' money to some extent, and we need to focus on not necessarily spending our clients' money on doing research. So we ended up, I think last year, investing about $42 million in research globally across 15,000 people. I think about 1,100 projects were research projects. And it's an extraordinary knowledge management system. If people are familiar with how Google does their 20%, we do it a little bit differently. People actually have to ask for the money. They have to put together a team. It goes through a web portal. And every one of the asks, it could be $5,000 or $100,000, every one of those asks gets vetted by a senior group who looks at whether or not Kevin did that last year, so no, you're not going to get money this year, talk to Kevin, for example. Or we don't think it's quite business aligned, so we're not going to invest in it, but about a third of them get investment. And so for us, if you look at that amount of money, that's about 100. It's over 100 years of people work time in a given year. So you imagine 100 years of effort, a 2,000 hour year. We have a a challenge on just managing that knowledge. How do you take 100 years in a single year and push it out into an organization? So research and innovation for us is a lot about knowledge management, and then applying that in pilots and test cases on projects with willing owners, whether those are owners in the built environment, kind of building side, or transportation, cities. That's where the kind of the piloting happens. And then we finish up that trajectory from research to piloting at a point where we want to scale it. So, Arup, despite our size, touches a very small portion of the built environment, and we want to make sure that whatever we're doing as a socially directed, mission-driven organization that cares about the future of the world, we're not locking that stuff behind closed doors. So we're very passionate, for example, in collaborating with academic collaborators and trying to get information out there, competitors, clients, collaborative research, innovation, and then scaling is of great interest.
Hi, I'm John Andary. I'm a mechanical engineer and a principal with Integral Group. And Integral Group is a mechanical electrical engineering firm, energy consultants, sustainability consultants. We're about 400 people in 14 offices in North America and London. Also, sort of mission driven. Our sort of tagline is deep green engineering, and that's a top-down thing in our organization. Trying to, again, understanding that the built environment is where the majority of energy gets used and water. We're trying to solve those issues regionally, globally, possible. And so personally, I'm been doing this kind of work for about 33 years, but only in the last dozen years or so did I really get excited about sustainable design. I'm from Florida. There was no talk about energy efficiency or water efficiency in my world, in the buildings I was designing in Florida. And but once the green building movement started to happen, and my son was like 2 years old, and I realized the damage that we were doing in our industry, it really kind of flipped everything on its head for me, and I dedicated my career to solving, in particular, the climate change issues around energy use in buildings. And there was I moved to San Francisco and ran an office for a very innovative firm, and we were really fortunate to win a transformative project, and it was this very large zero energy building at Andary. We worked with Shanti on this project, 360,000 square foot zero energy building, and the importance of that was what Andary was trying to do was to prove that large-scale zero energy buildings could be built at market rate. And so, as everybody knows, if you can do it, it's not going to cost any more money, and you can do something wonderful and great like that. Well, you're going to convince a lot of folks to do that. That's what Andary was trying to do. That's what we ended up doing with that transformative project. And ever since then, I've really been focused on zero energy buildings and how do you do those cost effectively and get it into the market, because then you can roll them out rapidly. And so recently been working on projects with developers, core and shell zero energy buildings, both new and renovations. There's some here in Silicon Valley that prove that there's a business case for doing zero energy projects. Recently, a project under construction with for a healthcare organization, a medical building. We actually proved that not only could you do it for the same budget, but by looking at a building and saying, this building needs to be an all-electric building because the grid's being loaded up with renewables, and once you put the PV on the side and on the building, you're going to get to zero energy. We don't want to burn fossil fuels in these buildings. Once I was able to convince the client of that, and we developed some strategies to make the building all electric, we actually saved them $1 million and gave them a zero energy building. So this is what my sort of mission is, and I think we'll talk about some more projects as the panel answer some questions.
Sure, yeah. I mean, let's get into the details here. I think that's a good transition. Maybe, John, in some of those recent projects and in the full panel here, can you walk us through a little bit about how your new technology discovery process worked, and how did you, what technologies in a recent project that you used enabled some kind of how this happened, and so for a question for everyone. I think everyone has their most favorite technology in a past project that they can tell us about, and how they found it, the barriers, the challenges in integrating it, and some details of what it is, why you thought it was innovative.
Well, as a mechanical engineer, in my previous life as a mechanical engineer, we're always looking for some technology that we, want to implement in buildings, and sometimes for all the wrong reasons, just because to say that you did it or to show it off at some ASHRAE show or conference. But since I've been more focused on sustainable green buildings, zero energy buildings, realizing that the best technology is good architecture. I see an architect sitting right here in front of me, and I'm not playing to you, but that's just the reality of it. In building design, in the built environment, good architecture can solve most of the problems of heating, cooling, and lighting buildings. And so, in a way, sometimes technology seems like the Band-Aid to fix poor architecture. But that's not to say that there aren't technologies that are going to help us get to that sort of low-cost, zero-energy building. One example, one building project example that has maybe two technologies that I'll throw out there. This project is under construction. It's in Boulder. It's a couple zero-energy buildings for a developer, and so the developer is looking for something low-cost, first of all, meets his pro forma, his business case, and but it has to be fairly simple and easy to operate. Because he's a small developer, and every project's different, but this is a small developer that's got to be a simple building. And so one of the things that we were looking at is to say, this developer is really sticking his neck out to do a zero energy building, core and shell, spec office building. One of the things we were thinking about is, how do we minimize the footprint of the systems in the building so that he gets maximize his leasable floor area. And one of the strategies we came up with is using something as simple as what we call a heat recovery ventilator. But these things have been around a long time. A lot of the technologies we use are not absolutely new. It's just using them in a creative way. So what we ended up doing for this fella is putting these heat recovery ventilators in above the ceiling. They're very flexible. They're very small. The technology has gotten quite robust. And so instead of having big shafts, air shafts down through the building, we've got the ventilators up above the ceiling and bringing fresh air in from the exterior of the building. And it was just a simple thing that ended up being very cost effective in order to get this project to net zero. The other thing that is another technology that's been around a long time, but using it in a creative way, is it's a 5-story building. Just using the roof, putting PV on the roof was not going to get to net zero. So we're looking at our options. Do we need a more complex and sophisticated HVAC system, heating cooling system in the building to make that happen? What we realized was because the cost of PV is so low, and we started to understand in that climate in Colorado, they get these really clear mornings, and so the southeast face of the building faced a light rail track for a new commuter rail. So we said, what if we just cover the side of the building with PV and make that the rain screen and make that the architectural skin of the building? And so we did that, and it turned out that it was so cost effective, it was only $1 a watt more for the PV to produce the energy we needed to get to net zero, $1 a watt more by making it the skin of the building than trying some other sophisticated HVAC solution. So those are a couple of interesting ways of applying a couple. Actual technology has been around a while. It's all about doing it in a creative way.
What I was going to maybe frame up is that given the topic of innovation and how it happens in the built environment, maybe that could kind of segue a little bit this way, is that in our experience, it happens through a couple of channels. So people who are, for example, entrepreneurs and product focused, like how would you kind of access the buildings that are being built? One path is that there are, it tends to be progressive clients that are generally on the smaller scale, that aren't taking as large of an economic risk. So whether that's a big client that's doing a small building, or maybe a more individual leader that is taking a risk on their project. So you can see a lot of these small projects that kind of demonstrate proof of concept or fail. Demonstrate proof of concept, and then you can track kind of over a decade, 2 decades, you can track how that technology matures, not just in its own capability, but how it matures into the industry, because people can point to what happened on the prior project. So that's one pathway. So if you're interested in kind of innovating in, I would say that's a pathway. The other is,
But that's a couple decades, right?
it takes, well, I think the just here locally, right? The Kirsch Environmental Studies building was one of the first projects to have radiant floors. A few years later, and this is what kind of segue in, within I guess the next 10 years, you see radiant floors for cooling purposes fairly widespread, right? There's a lot of examples of them. But that first project was 20,000 square feet, fairly small on the scale of building stock. But one of the ones that picked up radiant floors, for example, was Walmart. So the other pathway into innovation, I would say, are more of the experimental / research-oriented high-scale projects. So they're testing a lot of technologies in order to learn what's working and what's not working. Walmart was famous for this. They did the experimental stores. They did 2 different experimental stores, and they had license to fail. You know, they were producing so much content, and from a building stock standpoint, that they had a huge appetite to try technology. So if you can kind of, in Prospect, Silicon Valley, this is a fantastic link to Prospect, Silicon Valley, because one of the projects that is very similar to the Walmart experimental stores, which happened, I guess it was probably 8 years ago now. I mean, it was quite a while ago that happened. Is now Whole Foods. So Whole Foods has a large bunch of money that they're getting as part of the California Energy Commission grant to take one of the hardest buildings in the California building stock, grocery stores, and try to get it to zero net energy. And they're looking at over 100 different technologies, a lot of them pulled from you guys, from the industry in the Bay Area and abroad through Prospect Silicon Valley. So Prospect Silicon Valley put out a call for technology. They got a lot of respondents, and some of those respondents are going into the project. And that's 2 pathways that I want you guys to think about from kind of how products get into the actual built environment over time. And then I think the kind of the green proving ground, I was kind of thinking maybe that would kind of segue to how you guys are scaling stuff into your projects, in your buildings.
Well, you know, I was thinking about this, and I know the last, as you were talking, of course, I'm thinking, which is always a dangerous thing.
You weren't listening?
Yeah, I'm a terrible multitasker, I gotta tell you. So there was the last speaker, I think, was talking about how, you know, each of you, you know, these are your children, or like he was talking about his own technology being his child, and how could you not just love that forever? So we've had 62 technologies that have come through our Proving Ground program. And I have to say, even the ones that have catastrophically flamed out, I still love them, you know? So I'm the sort of person who loves all children, all dogs, that sort of thing. With that said, I think an interesting case in point, just, you know, sort of going off of that pathway, is what's called the magnetic bearing chiller. And you know, again, it's not a particularly sexy piece of equipment. And I think it's an interesting just sort of case study of how something occurs, right? There's essentially a small company in Florida, of all places, that comes up early days with just a different way of making a compressor, using magnetic bearing technology controlled, and this was the enabling piece, by low-cost compute. Really, that's what it was about, right? So it requires essentially a computer to run. And they, and I think again, it's a good story just sort of for the overall thing. They got themselves, there's a kind of a wacky dude in the Navy who they were actually ex-military people. They approached this guy. He put it into Port Hueneme down here in San Diego, tried it out. Seemed, actually, I think we had, was that NREL? I don't know, the PNNL looked at it. So one of the national labs did an evaluation. They said, hey, this thing actually is super incredibly promising, like 40% more efficient. That led them to apply to my program. Actually, we sort of asked them to apply. We tried them out. There was incredible skepticism, quite frankly, like if the computer fails, magnetic bearing, micron tolerance, seemed kind of expensive and risky. Again, incredible performance documented. I guess we used PNL for that one too. And so, we use national labs to do these things, but really proved out 40%, it really delivers that kind of performance in the real world. So even back then, and this is of course at this point the better part of a decade ago, I guess, well, not quite, but in 2009 or so, that was one of our very first results. We thought it was promising. The government has been broke, in case you didn't know, it's broken and broke. It's been that way for a while. So we didn't really have any money. We used the corner check cashing store, so to speak, which is we call ESCOs. Uh-oh. Anyway, hopefully that's not the NSA listening. Anyway, we use ESCOs. ESCOs are very conservative in terms of the technologies that they like to deploy, because ESCO, Energy Service Company. And so the Energy Service Company basically works on the principle that they guarantee energy savings. And the delta between what you are paying today and the reduced energy that you will be paying after you put in some piece of technology finances that piece of technology. So if you are going to save, whatever it is, $10, that's the stream of money you pay. Well, if you think about it, they need to guarantee that those savings occur from the technology you're putting in. So if you put in a magnetic bearing chiller that we think is 40% more efficient, should save a lot of money, and yet it could fail could just fail out of the box, seems kind of risky, weird. They price in the risk that it will fail. Actually, they wouldn't touch it, to be perfectly honest. They didn't want to do it. They wanted to just put in a regular, good chiller, not a great chiller, but that sort of thing. We convinced them using, thank you taxpayers and former President Obama, Recovery Act money. We bought down the risk. We put in a bunch of these chillers because we have one guy in Texas who believed in that green proving ground study. He figured out the finance to make this happen and buying down the risk, and it was super complicated legal stuff. We then put in, I think, about 20 or 30 of these. Again, this is just how it goes. They still seem pretty weird, but they all delivered, right? People started saying, hey, this stuff really seems to work. I'm seeing huge changes in my energy bill, and actually these things are really quiet, which was an unintended benefit. So then you could have occupied space a little closer to the chiller without people complaining. Seemed really good. Now, fast forward to today, we have, at this point, I think 220 that we have deployed. We're saving almost $2 million a year as an agency because of those. So you can see that they're delivering. And now you'll have people who say, oh, this is accepted industry practice. And I can certainly tell you it was wacky 10 years ago.
I just want to generate so much money that you guys can buy all the technologies you want and make every building net zero. Only because I've been engaged in this business long enough as a seasoned partner to go from pneumatics to the first DDC, all DDC building in San Francisco in 1988, 600 California, not a pneumatic compressor on the job. And I've seen from VAV and chilled beam and underfloor and Lawrence Berkeley National Laboratories and the Flex Lab and UC Berkeley and Stanford and Cornell and Vivaldi and Lofness. I've been at technology in terms of building science my entire career. And I think we're playing at the wrong end of the fuel gauge. Right? If energy is 3% and you go to 0, you save 3%. And all it is reducing a liability. If you understand that buildings are built for people, whatever we can do to improve the quality of a space for people will ultimately end up increasing their health and their productivity. If for instance, let's do the math, right? We all talk about 8,800. And the goal here would ultimately be, without sacrificing anything on the planet, if you have a 100,000 square foot building and a 200 square foot a person, which is nominal, probably generous by today's standards, that's 5,000 people. And each one of those people earns $100,000 a year, and you throw a little extra for benefits. Each one of them makes $150,000 a year. At 5,000 people, it's $75 million worth of salary per year. The entire energy consumption on that building is $1.5 million per year if it's 2 to 3%. If I improve the efficiency of the population in that building by 1%, I have paid for half of the energy in the building. I virtually almost made every building a net zero energy building. And I say that because we have, as a professional, I am one, we strive for do no harm in buildings. We put in fire alarms for the catastrophe, and sprinklers for the catastrophe, and security for the catastrophe. And yet, the ability to recognize we can make meaningful change in the health of this building by the air we breathe, the light we absorb, the acoustics that we have. And you can get 100% participation by providing those elements where you can't turn off your ears, you can't close your eyes, you can't stop breathing, you can't stop breathing. So I'm not talking human resources policies here, right? I'm not saying putting bananas out on the table so that everybody eats bananas all day long as opposed to M&Ms. Those are good things, right? I believe in nudge architecture, hiding the M&Ms, putting the bananas on the table, celebrating the stairs, doing all those elements. But the ability for us as an industry, from a technology perspective and a practical application, to say, if I not only improve the productivity of those people in the short run, I'm going to have a long-term effect on public health. Because we are in buildings 90% of the time, and just like I said, 90% of the money, real dollars, $75 million worth of salary versus $1.5 million in energy every year. I don't know how old you are. I know how old I am. I turned 60 years old this year.
Okay.
It's pretty cool, right?
Congratulations. Happy birthday.
90% of 60 is 54 years. Do your own math. How many years have you been in a building? It's not an arbitrary 90%. So the ability to recognize buildings have a phenomenal opportunity to improve health and wellness is key. And we don't have to invent anything. We just have to turn to Stanford and Mayo and Columbia and Cleveland and MIT and Johns Hopkins and Cornell, because the way to improve buildings already exists in peer-reviewed, evidence-based journals.
Just have John open the shade there.
Yeah,
You?
yeah, and drink some water. You know, so I guess I'm saying this because everything that we do needs to have a multiple purpose. I'm a strong believer that LED lights are going to last a long time, provide high quality light, be a benefit to the environment, and provide the right kind of light we need to help us be healthier human beings, because we're in buildings 90% of the time, and fluorescent light and incandescent light is nowhere near what Mother Nature intended. So I think buildings need to be as invisible as they possibly can. I think they need to conform to the environment we put them in, whether it's Golden, Colorado, or Panama, or Saudi Arabia, as opposed to put the building here out of the planet conform. And I also think that buildings need to be built for the people who are in them. The very reason from a business model perspective. So anybody here who's an entrepreneur, anybody here who's a designer, any of us up here who come with that kind of tested experience, need to say, what am I doing for the people in the building? And how can I optimize their performance and put it back into my building? So I had somebody say, Phil, you recognize that if this is true, and I know it's true, then no one's going to want to pay attention to the energy anymore. They're all going to be focused on the people because we only see one thing at a time. We're very siloed individuals. And I said, only if we let it. The ability to provide that technology that's good for the people and the planet, that's the elegant solution. Right? So
what's your favorite then?
absolutely. I think light. I think light is a huge element that we've ignored over the course of mankind. In the fact that light is one of those elements that puts us to sleep, wakes us up, controls our digestion, controls our cognitive skill sets. And we have an opportunity to transform how we light buildings today because of the LED technology. Let's do it smarter. It's not a matter of more, it's a matter of smarter. And I think we need to pay attention to the quality of air we put in the space. Some of it's based upon the materials we put in the space. Huge cognitive studies that were just done by Harvard that don't talk about 1 to 2%, but talk about 5, 10, 15% improvement in cognitive skills based upon the air that we breathe, based upon CO2 and VOCs, and let alone the long-term damage that we see from formaldehyde in spaces. Key things, smarter money, not more money. And by the way, consumers care about it. You know, I hate to say it, consumers maybe recognize a LEED building. They might recognize net zero energy building. But to be transformative, let's do things that the occupants really care about, whether it's a single family, multi-family, student, school, or office building. You can talk about the people in the space, the very reason the company exists or the buildings exists. I think we can gain an emotional appeal that will also help us do the right thing for the planet. This needs to be about creating a different business model where the people who produce quality buildings get rewarded for the productivity of the building. It's like P3 for people, right? That, in other words, public-private partnerships were designed to deliver on time, on budget, and the energy. How about you also get paid for producing the environment and higher quality for the people in it? That would be just an interesting business. The one thing we asked for architects, we asked for engineers. We didn't ask for any doctors. Are any doctors in the room today? Hopefully there's some MBAs in business, right? Some folks in business. The fact is we need to merge health science and building science and business. That's the three-legged stool that I think will be incredibly powerful to improve their building performance.
There's a quick follow-up. You know, we measure light levels, right? We have thermostats in the wall to measure temperature, and now we're in CO2.
The dumbest thing in the room is the thermostat.
Right. Are there any emerging technologies that start to try and get at some of more of this measuring, spaces for people that you're aware of? I mean, are we starting to see that more, or is it still just thermostats and lights also?
I think we've seen products that are wireless, web-based, that do humidity, that do CO2, that do formaldehyde, that do light, and do acoustics. And they're going to be able to provide environmental metrics. And pretty soon they're going to be wearables. We see some major developers scared out of their wits because people who walk into the building are going to know more about the building than they do. So the ability to talk about a smart building means smart and healthy. To make a smart city, it's a smart and healthy city. So I think those are very uniquely tied together.
I would say that if, assuming we don't get sunk by cybersecurity challenges, for those of you who haven't heard about, Cisco calls this, or their branded name is the digital seal. And and I think it helps explain the concept, and it doesn't have to be Cisco's technology per se. But the fact is there's this ubiquitous plane up there that is relatively omnipresent. It has, in the past, of course, lights, and we heard in the beginning that Edison invented this thing, not a lot changed really. At this point, LEDs, just to be clear about it, they are computers. So every single light, as it moves to an LED, is essentially a computer. It doesn't take, again, Cisco's in the business of selling switches and so on, so they have a lot of invested in this. But the fact is that having a bunch of computers up there gives you the opportunity to have a network up there. If you have a network, and it doesn't, again, have to be wired, it could be wireless, there's many different ways of doing it. And if you have the ability, as we do, to have sensors with multiple channels, all those things that Phil was just saying, whether it's light or humidity or air quality or sound, you can have all those channels plus the compute, beyond the compute that took the Apollo to the moon, plus a wireless radio, and you can make that for 3 cents, which you can. That tells you that you're going to have a lot of distributed intelligence in this digital. You could have a lot of digital intelligence in this omnipresent environment. And then, of course, the lighting itself, because it is computers, actually has the ability to track anything that's in the horizontal plane. Could be scary, but nonetheless, it essentially has digital communication with anything it can see and anything that can see it. So we're going to be in a place of ubiquitous communication, which is really pretty interesting. And we also have, with the LEDs, we have the ability to tune the color spectrum to whatever you want, whenever you want it. You have the ability to individually adjust each light within a commercial space. This has never been able to be done. So when you think about that, it's, I think it's super exciting. To my mind, I think the term I've heard is that there's the human in the loop, but the idea is that we are going to be in a place where we can expect our environments to respond to us, to what we need. And like Phil says, we're spending 90% of our time indoors. It'd be nice if that time was comfortable and sort of to our preference. And in the past, that's really been challenging to do. There's just some logistical reasons why it has been. And in the future, it's not going to be challenging, and we're going to be able to do it. So I'm pretty excited.
Pass.
Pass.
Well, I don't know if we all have to answer every question, so
No,
I
yeah,
think
no,
those
I
are
mean,
great
I-
answers. And
I do have, there's one incredible technology that I just recently came across. The company's called Jabil, Jabil, and they're one of the largest manufacturers of everything in the world. And they're getting into the energy field, and they've been able to develop a product that can go in, and they've done this on their own buildings. In a week, they have these sensors that can go on literally every wire coming out of every circuit in a junction, in an electrical panel, and every outlet, and just and analyze how the electricity is being used, the pattern of how the electrons are moving through those wires, and do 500,000 square foot of building in 1 week, and deliver all that information back and tell you exactly how each one of those circuits and each one of those outlets is using energy and what is being plugged into it. They can tell one printer from another by analyzing the outlet that's plugged into by analyzing the way the electricity is used. It's absolutely unbelievable, because the biggest problem is all the existing building stock we have, not what technology we're going to use in the very next zero energy building, but the millions and billions of square foot of existing buildings. If we understand how we're using energy in those buildings a lot more rapidly and effectively, then we're going to solve the problem.
do you see a disconnect in that, every building having to have a network professional on the facility staff to be able to do something with all this information that we're
Well,
collecting?
I'm going to give an immediate knee-jerk response that actually somebody else and I were talking about this last week, and so we were really talking about the lighting, but it could just as well go for the smart sub-metering or anything else. And so what he said, as we were sort of talking about some of the challenges that smart buildings require very smart people to make them smart, and I sort of flippantly, as I want to do, said, well, what we really need is clever buildings, and that is to make stupid people smart. So I didn't really think about it, but I've been thinking about it a lot more since, and I think that, when I started out, you had to you get your computer, and it was a real chore, even if it was an Apple, which was easier, to configure the thing to work. I mean, Apple's big deal was that it was a lot easier to configure than the PC, and the PC required really essentially an IT professional to make it work. Nobody doesn't regard, whatever platform, it works out of the box. You take your iPhone out, you're not an IT professional to get all the functionality out of your iPhone. So that to me is where things are headed. We're going to make clever buildings.
I could add to that. I think that having a lot of systems converge. The challenge has been a lot of the control systems have been disparate in buildings, right? And you've got kind of this bifurcation, but like 4 or 5 different pathways in a building to incorporate different control systems, whether it's lighting control systems or HVAC control systems or security control systems, and that's hard to operate, right? When you've got all of these different things and different protocols and different manufacturers. So I actually think that it's going the other direction, where and we do a lot of smart building consulting, and one thing that allows us to kind of do that is the knowledge of the HVAC system, the knowledge of the security, because we do security consulting, AV acoustics consulting, IT consulting, lighting consulting, and you can see it that they have a convergence pathway, and we just don't necessarily have that design professional on every team to converge all of those things, or the contractor on every team to converge all of those things, or the operator at the end to make sure that all those things are being operated as one integrated system or converged system. So I think it should get simpler, not more complex.
Yeah, I tend to agree. There's, we're all waiting for the smart building to magically appear, but in the meantime, I'll go back to what I said earlier. In a way, what I'm seeing on my projects, while I can't get this amazing backbone to actually happen, where everything is controlled from one system. What I'm realizing is that if we're doing a good job, again, with architecture, if we've got a good passive building that's has daylight autonomy, that doesn't require complex mechanical systems to heat and cool them, then you can have very smart systems that operate on their own, and all you really want to do is collect the data from those. We just opened our 4th zero energy retrofit project here in Sunnyvale. We essentially kind of using the same technologies in every building. There's no big backbone for these zero energy projects. There's electrochromic glazing that works on its own. There are ceiling fans that sense when somebody's under them. They work on their own. The lighting system, of course, works on its own, but it's almost always off because it's 100% daylit. The HVAC system has its own control system, but it's off almost all the time because the building stays within the temperature range we need it to passively most of the time. So, there is a way to design around avoiding the smart building, or say waiting for your smart building to happen. You can do this in a way that if you're doing good design, if you're taking good measures with your architectural design strategy.
I'm going to play upon something if I can. The ability to recognize that 98% of the building stock is existing. So the biggest challenge is to make our great buildings slightly better. It's admirable, it's needed to be done, that's that 1%. But so I think some of our largest challenges would be, if you're in an entrepreneurial business world, do you want to wait for the 1 or 2% to drive your business? On the variation of the economy, in 2009 you went out of business, in 2018, 17 you can't build it fast enough. Kind of a rough business. So real estate is not necessarily stable. Most financial institutions view real estate as slightly above junk bonds in terms of their overall real estate risk. Right? We need them. Right? I would think that what we do is concentrate on those things that I love wireless, because wire does nothing except consume time and resources, and just potentially breaks, get ripped out, and is old and hangs in the ceiling forever. So whatever you do, have a technology that if you can, be wireless, whether it's wireless power, wireless technology, I don't care what it is, whether it's based upon photovoltaics or whether it's based, whatever you, in technology perspective, if you can get away from being tethered by something else, which is all, by the way, another trade. It's an electrical trade, it's an IT trade, it's probably not your own technology. So stay away from it if you can. It also means you're going to have a big play in existing buildings. You don't touch walls, you don't touch ceilings, you don't touch that asbestos nobody knew that was ever there. So it's all those kind of things that if you can stay technology driven, which really turns out to be something no more than this. Okay? And I'm going to give a little term. So the ability to say that's also not just where 98% of the square footage is, that's where 98% of the people are. So the ability to give yourself a continuing income stream, I think, is extremely important. It also means that we can potentially start to affect the growing part of the world that isn't North America or Western Europe. It gives you access to India, it gives you access to China. There are no telephone poles in China, right? There was no Pac Bell, there was no Ma Bell to worry about. So we still have some North America issues to work through. We've all heard about the Internet of Things, and then but the Internet of Everything. How about calling it the Internet of You? I think it'd be IOY. Because I think everything in the building ultimately should be for Phil's comfort, for Phil's nutrition, for Kevin's nutrition, for Brandon's nutrition and comfort and fitness, and the ability to really start to make it centric. Because I know I have virtually no control over anything in this space. That thermostat doesn't listen to me, the light switch doesn't listen to me, And yet it's supposed to be working for me, but I have no connection to the space. So whether it's Cisco or whether it's that smart EC building, the ability to say that Internet of You, make it about people, make it about wireless, it'll give you huge access to the rest of the marketplace. It'll avoid uncostly or extremely costly supply chain issues, because a lot of what you guys have are supply chain issues. A lot of what we have are supply chain issues. I would really ask you to look about that. And I think it's an extremely powerful tool, simple, elegant. Don't try to reinvent the cell phone. I think there's going to be as much work on coordination of apps for people that I'm going to get data that's pushed to me. You know, if I like 72 degrees and I got a jacket on and someone else has got shorts and flip-flops, I think that we're going to have the flexibility to know where the building functions, where it's quietest, where there's the light for fill, where's the acoustics for fill, where's the temperature for fill, and that we're going to have that individual control. If to follow up on yours, what's the newest, interesting, most technology? I would say let's create inanimate objects like furniture that directly touches me, that can potentially increase my thermal comfort by ventilating, by heating, by cooling, where I control it, where it moves with me, it moves into an existing building. It'll let my temperature vary wildly or dramatically, because it creates a very neutral space. So look for things like furniture that are actually personal comfort devices that are readily transferable, move with you. May let a new startup company not invest in a heavy HVAC system. If you move, it moves with you. Some pretty cool things out there on personal comfort devices that, oh, by the way, are Bluetooth connected and aren't simply inanimate objects. Pretty cool stuff.
So we have 15 minutes here, and I got one maybe final question for the panel here, and then we'll quickly kind of move to the audience here. So you know, I get to at Andary, I get to work with the Wells Fargo IN2 program to bring new technologies to the market, right? And startups that are trying to bring new technologies to this large kind of infrastructure industry that we're, you know, the largest industry, right, if you will, is the U.S. buildings industry, right, in terms of the full kind of impact on the market. And so, what do you look to for, you know, what type of programs, what type of incentives? Is it, you know, case studies? Are they lab validation efforts? What do you think is, you know, programs that you look to for bringing these technologies so that not just ARUP and Integral Group can use them, but, you know, there's 60,000 ASHRAE engineers out there and 80,000 architects out there that are designing and building buildings every day that may not be the leaders of the industries out there to kind of move this market forward. So, follow up a finishing question here, I guess, before we go to the audience.
How to scale?
Well, it's not just scale. It's how do we support you know, the new technology incubator industry, right? There's a lot of technology out there. I mean, it's a full-time job just to kind of keep up on all this new technology that's either lighting or heating or cooling or envelope architecture, energy modeling, right? Chillers, plug loads, data centers, right? All this has their own set of new technologies coming to the market. How can, what type of programs that whether it's like the Green Proving Ground program or utility incentive emerging technologies programs that are out there. They're all trying to bring new technologies to the market. How do you see that best being streamlined?
Well, you know, we had, maybe I'll
Yep.
jump in with you guys.
Yep.
So we had a conversation actually kind of on this a couple weeks ago at the AIA Next conference, and how innovation kind of scales across,
Yep.
and what is exactly happening in this industry, because there is a little bit of a question mark with current government funding, and what if you look kind of traditionally, what's generally happened is there's been a very nice symbiotic relationship between innovation, best practice in at points in time, little small kind of clues and pop-up case studies, things like that, that are captured and supported, oftentimes either funded in kind of when they're government-funded pieces that are kind of pop-up, or are scaled through government capturing those ideas and then pushing them back into the marketplace as standardization. And you can say government, in some degrees, it's standards bodies. But there is a question, I think, about what is the role as the federal government maybe moves away from necessarily playing that same role in the future, and whether it will or not. I mean, it may actually increase, right? We had a discussion about where the funding is going. But if you look at that, I mean, what is the role of? It's easy when the innovation in the technology makes so much sense from the beginning that it saves money on day one. You've got you've got a client that puts it in, and they scale across, and it's like business case, poof, done. There's a lot of technology that has large hurdles to enter into the marketplace, and those are real cost hurdles, and they do not make cost sense on a project, right? The owner is paying, if they're testing them on the project, they're paying a premium for that product. And they're doing it for some other reason than because they want to make money for their building or save energy or make the space more comfortable for the occupants. So that to me is actually kind of a bigger risk and concern. I'm worried about those technologies that don't have a clear, immediate short-term market driver, like financial, but have huge upside potential in the future. So for example, I'll give you an example of this, and this is future climate. So future climate, one of the research projects that Arup was working on is, if you look at the built environment all around you, it's all designed with weather data in mind, whether it's streets, whether it's sewer systems, whether it's buildings. Weather data kind of promulgates through all of the design decisions. And those hundreds of thousands of designers are making design decisions every single day based on inaccurate historic climate information that in some cases is 50 years old. And these buildings are going to be around for at least 40 years, if not hopefully a little bit longer, maybe they're better than that. So at least maybe the end of the century, if we say in some of the better buildings, there's no market driver for us to apply future climate data to buildings today. The technology exists, it's out there, it's cheap, it's known to some degree in the marketplace. Nobody's asking for it on the client side. There are a few kind of small indicators of people saying, oh, I want to try this because scarcity kind of plays a role. I want to try it here and try it there. But the hundreds of thousands of decisions that are being made by all of these individual practitioners, there's no market driver for it. And market drivers only occur, if you look at why people take up things like LEED, early on LEED, people were interested in it because it was scarce. So scarcity can promote market action, right? But why is it successful today? It's not successful. It's definitely not successful because it's scarce. It's successful because there's authority saying people have to do it, or because everybody is doing it. So there's kind of common practice, normative behavior, it becomes the standard. And getting from a few blips all the way up and bridging that divide is the challenge I'm more interested in than testing an individual technology here and there on a dozen buildings.
I want to just jump in really quickly to return to the story of the maglev chiller, and because I think it's instructive. So here we are, we're going along, we're specifying them. It's considered now to be sort of state-of-the-art practice, but accepted state-of-the-art practice. But the truth is, and this is where I think a lot of this breaks down, it is, as Phil said, it's not about the 1% of new buildings, it's not about the few people who have Arup and Integral doing their engineering, but it's about the vast majority of folks out there in the, as we would call it, the supply chain. And the fact is that we, in a highly scrutinized particular place where I happen to be very involved for a variety of reasons, we wanted a maglev chiller, we asked for a maglev chiller, we got a maglev chiller. It wasn't the right one. That was from the rep, the person who, we had to tease apart, where did this break down? It was actually the manufacturer's dealer, the rep for the manufacturer who specified the wrong machine. Now he specified the wrong machine for a very basic reason, which is he didn't understand how it worked. And he was specifying it based on how you would have specified a non-maglev chiller, because that's what he knew. And we paid too much, it doesn't operate right. Then the O&M comes along, and they're like, this thing is really finicky, I can't really run it right. And they probably will break it. And it will cost a lot more in maintenance, which again would get people all turned into the wrong place. That's, and this is like, these are well-intentioned, relatively educated people in a very sophisticated metropolitan market. Now imagine how it goes as you sort of diffuse out. So I'd say that to my mind, the real, and I heard earlier today this story about like when we have these driverless trucks, which I think is going to be one of the very first things. There'll be all those drivers of trucks who won't have any jobs. And you can sort of think about how this all goes. But basically, and then there's this always pushed off to the side as well, we've got to figure out an education program, a re-education, or training, or this, that, the other. We don't do that. And there's really, there's even under the previous administration, there was really not a lot of resources devoted to education. It's just not sexy for some reason. So if we don't educate the workforce, this broad set of folks that are out there, there's going to be some problems. And that to me is the biggest, that's the biggest barrier. We better, yeah, sorry.
Great, so 6 minutes according to that clock. So take some questions from the audience here. Yeah, in the back here.
Hi, Mariana Grossman. I want to build on a comment Cole made. Most of the conversation seemed to be about the relationship of the occupant of the building and the building from the inside. But with climate change, changing temperature and weather, flooding, drought, subsidence, fire, all those kinds of things, how do you make the building resilient, existing buildings or new buildings resilient to these new changes? And if climate change is a tragedy of commons, how do you have a market take that into account? Do we need a price on carbon? How do we get people to think ahead about these impacts when the insurance industry sort of goes year to year? There aren't the kind of levers to get their attention, to get your attention, to think about what are the technologies to help us solve those problems.
I guess, my comment is that knowing how buildings are built, they're not that precise. I hate to say that. So most of the buildings that we built today have got about 25% extra capacity because we're worried about somebody, unless it's a truly passive building where a half a degree or a degree is going to make a big difference over a decade or two. It's the swings. And so I think from that perspective, it may be more about what is those major catastrophes. If I were in Miami, I'd worry about a hurricane. If I were in San Francisco, I'd worry about earthquakes. If I'm by the ocean, I'm going to be worried about water increase, those kind of an elemental part of it. And so the good part about it is that we're not necessarily building Swiss watches. So from a building's perspective, I think the environmental systems we put on it are probably fairly, are probably not very fragile. I think our food chain is fragile. I think our water chain is fragile. So whatever we can do to minimize our consumption is probably going to have a much better effect on our supply chain in terms of Mother Nature. It's going to survive with or without us. It's really just how we're going to survive.
So my take is it's early days for that question. I actually don't. I think the answer is still out there as to how fragile our buildings are. Certainly, when we've tested it on some buildings, there are buildings that are being designed today by Arup and Integral and probably people in this room that expect a certain climate, and they are being designed for passive performance. And those buildings, I think, have a legitimate risk in the future. And those buildings, for the most part, whether we're doing them or others are doing them, are not being stress tested for future, meaning that the owner is going in uninformed about how their asset is going to perform in the future. So that's the passive is kind of one play. When you talk about the other side of it, I would say, is that to some extent we select systems based on an expectation of certain energy use and certain performance attributes. And that drives what systems go into the building. And those systems may actually not be the right systems for the future insofar as the most optimal system. So energy recovery is a good example of that, expecting whether or not there's going to be more or less potential for energy recovery, especially at things like district scale going forward in time. The other big example is case study that drives our codes. Our codes and standards are driven based on casework that happens at the state level. All of that casework happens through modeling and analysis, and it's using historic old data, so you could say that our codes and standards are potentially undermined by whether or not it's appropriate for the future. And that's just on the energy side. That's not even talking about water, right? And there is a significant change in potential water. And when you talk about putting a pipe in the ground, it costs a lot to put a pipe in after you've already put one in. You want to dig up the old one and put a new one in. It doesn't cost that much more to increase it 2 inches. So I think what's unfortunate is that we're not we're not even being informed. We're not thinking. We're just kind of defaulting to say it's either okay or we'll just go off of the past. The positive thing is that the policy signals are going in the direction of requiring it. So already the state of California has said to all of their agencies that they need to consider future climate. That's kind of happening, I would say, but it's not really happening when you get to the design of buildings and infrastructure. Sea level rise is probably the best example where it is happening, but not climate and rainfall.
There's a great term I use. I think if we use the term future-proof, it's a defense against change, it's a denial against change, it's that we're somehow going to do 4 feet of concrete. I like to use the term future-ready, the ability to recognize there's some things we don't control from a resiliency perspective. Do you build a building that's never going to move in an earthquake, or do you build a flexible 2-inch, 4-inch pipe? I think that's the future-ready concept. That means we can't control everything, but be aware of it.
Anyone else?
I'm sorry, I have a follow-up comment.
Anyone else?
I talked to somebody who has a building right near here who said, oh, we built it 7 feet above flood, but he didn't take into account, well, what about his parking lot, or what about light rail, or the roads, or, so it's not, the buildings can't be in isolation when you start to think about climate impacts as well.
Do I have a second?
Yep.
So there is going to be one positive. I think that there's some. There's a tendency to kind of think doom and gloom about future climate change, and I am definitely on the bad boat. Right, future climate change is not a good thing. When we've stress tested some of our projects, Phil is absolutely right. They actually perform fine, right? So we've actually said, check. They're gonna, the worst case over the next 100 years, they can make it through, and that's good to know. I think that some of the interesting stuff that's happening is when we start to price in resilience and what resilience is worth, what risk management on a project is worth, and that also is kind of a new and expanding space. There's been a lot of focus on seismic in the past that's now being ported over to climate and other hazards, whether those are heat waves or tsunamis or typhoons. And that, I think, is kind of interesting, because when you talk about, there's a website that I think is live right now called Solar Resilient. And you can go to Solar Resilient, and it was a DOE-funded project, yay, Fed, right? It's a DOE-funded project looking at how do you get solar energy, battery storage, and emergency preparedness planning all linked up. Because there's a lot of places when a hazard strikes, when an earthquake strikes, for example, where people can't shelter in place and they have to find shelter somewhere else. And those are libraries, they're churches, they're rec centers. Those types of buildings, for the most part, don't have power. So this study was focused on how do you take a portfolio approach to all of those buildings, and there would be, say, 200 odd buildings just in San Francisco like that would shelter about 50,000 people for about 3 days. How do you take a portfolio approach to all of those such that they can actually provide a significant portion of their power during that outage? And that's a great example of, I think, something that can scale. It can go to Atlanta, it can go to New York, and that's a DOE-funded, California participating piece of work that is now being scaled and shared nationally, and I guess you could say internationally, because anybody can get to the site. So very positive. Solar resilient.
Solar resilient. Great. With that, thanks to our panel for